So this is for integrated 3, chapter 8, D-Day number 3. So on this first problem, we have to get this to be a single logarithm. So this is going to be log base 2 of 2x squared minus 4x, because when we have two logs that are adding, that are the same base, we can take it and make it into a single logarithm and have the product of what we are taking the log of is equal to 4. Then we're going to rewrite this in exponential form. So my base is 2. Remember that your log is always equal to the power. So this is always the power that you're raising your base by. So you're going to go 2 to the 4th is equal to 2x squared minus 4x. So we're going to have 16 is equal to 2x squared minus 4x. So we have a quadratic. We are going to get 0 on one side, everything else on the other side. So I'm going to subtract 16. Myself personally, I notice that everything here is divisible by 2. So I'm going to divide everything by 2. I'm allowed to do that because I'm even dividing this side by 2, but 0 divided by 2 is 0. 2x squared divided by 2 is x squared. Negative 4x divided by 2 is a negative 2x. And negative 16 divided by 2 is a negative 8. So now that's what I'm going to solve. I'm going to factor that. So I'm going to have an x minus 4, x plus 2 equals 0. So one answer is going to be x equal 4. Another answer is going to be x equal negative 2. Now, you always want to check when you have logarithms and look back at your original problem that you're not taking log of a negative or 0. So if I put 4 in here, that's going to be okay. It's going to be okay here. I'm not going to get 0 or a negative. But when I take my negative 2 and put it in here, I get a negative, and I also get a negative here. So this one is not going to be an answer. So the only one that is going to be an answer, let me just do that kind of more in a see-through. That one's not going to be an answer. So the only one that is going to be an answer is x equal 4. That is our answer. On number 2, sketch a graph of this function. So first off, I'm going to look and see, this is a power of 1. This is 2, so that's going to be 3. 3, so it's going to be 6. This is going to be a negative degree 6. And so since it's a negative degree 6, all even degrees are like parabolas in the sense of their end behavior. So a positive parabola would be opening up and down. This would be like a negative parabola. Okay, so what that means is my end behavior is going to be down, down. That's going to be my end behavior. I also need to find my x-intercept. So I have 0 here, which is a single. I have 3 here, which is going to be a double. And I have negative 4, which is a triple. So I am going to graph this, not caring about my y-axis, just my x-axis. So this is going to be 4, this will be negative 4. So when I plot my zeros, I have a 0 here at 0. I have 1 at a positive 3. I have 1 at a negative 4. And then I want to pay attention to this is going to be a double because of that square. So this one here is going to be a double. Just want to focus on that. And this one here is going to be a triple. Okay. So this one here is going to be a triple. And I'm going to be starting below and ending below. So when I come back and graph this, I am going to be coming to this one, which is going to be a triple. So I'm going to have it be almost like half of an open down. Then it changes concavity and it kind of becomes half of an open up. That's how I kind of think about it. Then it's going to go through this, which is a single. And then here, this is going to be a double. It's going to bounce off. On number 3, we're going to use synthetic division to divide. So when I'm doing that, I ask myself, what will make that 0? -5 will make that 0. So I'm going to put -5 here. I want to make sure it's in descending order and I'm not missing any terms. So I've got a 3, 13, -12, -11. I am missing my x term, so I'm going to put a 0, and then I have -1. So any degree I'm missing, if this one's a degree 5, if I'm missing 4, 3, 2, 1, or the constant, I need to put 0 in its place. Okay, so I'm going to bring down this 3. 3 times -5 is a -15. I combine and I get a -2. -2 times -5 is a 10. I combine, I get a -2. -2 times -5 is a 10. I combine, I get a -1. -1 times -5 is 5. I combine, I get a 5. 5 times -5 is a -25. I combine, I get a -26. So when you're doing this, whatever you get at the end here is your remainder. Okay. So first off, this is telling us that x plus 5 was not a factor. Okay. But it doesn't mean we can't divide, it just means it doesn't divide evenly. Also, you need to pay attention to the degree that we were starting with. We were starting with a degree 5. We will now have what we call a depressed polynomial. And that polynomial is going to be 1 degree less. So since that was a degree 5, this is going to be a degree 4. So my answer is going to be 3x to the 4th minus 2x to the 3rd minus 2x squared minus x plus 5. And then my remainder, it's a negative, so I think I'm going to write it as a minus 26 over x plus 5. Or you could do plus a negative on top, 26 over x plus 5. And that's our answer. On number 4, write the exact equation. So exact equation means that I need to find my a, and I need to pay attention to a couple of the things that's happening here. So it says that we have roots at 0 and 3. Doesn't say anything special about that, so I assume those are going to be singles. It also tells me it bounces at -1. That's telling me that it's a double root, that's a square. And then we're going to use this because it passes through this point. That's what we're going to use to find our a. So I am going to have y equal a. And then my 0, that's going to come from the factor of x. My 3 comes from x minus 3. And then bounces off in a -1. That's x plus 1 squared. And then I'm going to put in 2, 12 for my x's and y's. So I'm going to have times 2 minus 3 times 2 plus 1 squared, and then we're going to work it out. So when I'm working it out, I'm going to get 12 is equal to a times 2 times 1 times 3 squared, which is 9. So I get 12 is equal to, oh, and this is going to be a -1. So I get a negative 18a. So I get a negative 12 over 18. Or if I reduce that by 6, negative 2 over 3. So my equation is going to be y equal negative 2 over 3 x times x minus 3 times x plus 1 squared. Find the remainder. So if I'm dividing by this, I'm going to put -6 here. I'm going to have 7, 40, -12, 15. I'm going to bring this down. I have 7. 7 times -6 is a -42. I add, combine, I get a -2. -2 times -6 is a 12. I add, I get a 0. 0 times -6 is a 0. I add, I get a 15. They wanted the remainder, so the remainder is 15. On number 6, they want us to list all possible rational zeros. So my Q is going to be my 2. So that's going to be either ±1 or ±2. My P is the 7. That's going to be a ±1 or ±7. We put P over Q. So on top, I'm going to have a positive -1 and a positive -7 over positive -1 and positive -2. So I'm going to focus on putting both of those over 1 first. So when I do that, I'm going to get ±1, 1 over 1, ±7, because it's 7 over 1. Then I'm going to focus on doing it over the, oops, sorry, trying to change the color, over the 2. So when I do that, again, I'm taking my 1 and 7 over 2. I'm going to get ±1 over 2, ±7 over 2. Those are going to be my possible rational zeros. On 7, find the zeros of x to the 4th plus x to the 3rd minus 8x squared minus 9x minus 9. So looking at my Q is just going to be 1, ±1. My P are going to be factors of 9, which are ±1, ±3, ±9. So my choices are going to be a positive -1, positive -3, positive -9. So I'm going to do this in a table form. 1, 1, -8, -9, -9. Let's say I start with 1, bring down my 1. 1 times 1 is 1. I add it, I get 2. 2 times 1 is 2. I add it, I get a -6. -6 times 1 is a -6. I add it, I get a -15. -15 times 1 is a -15. I add it, I get a -24. Okay, let's try a 3. So I'm going to bring down my 1 again. 1 times 3 is 3. I add it, I get 4. 4 times 3 is 12. I add it, I get 4. 4 times 3 is 12. I add it, I get 3. 3 times 3 is 9. I add it, I get 0. So I found a 0. So I know right now that one of my answers is going to be x equal 3. Make sure you write out your answers. I now am going to take this smaller polynomial, 1, 4, 4, 3. Now, what I notice is all of my numbers are positives. So using a positive 9 is not going to help. Okay, and then you might try a 3 again, but again, because it worked once, it might work again. 1 didn't work, so you don't try that. But since these are all positives, there's no way when I multiply by a positive and add that these are going to cancel out. So I'm going to try my negatives. So let's say I try a -1. I'll bring down my 1. 1 times -1 is -1. I add it, I get 3. 3 times -1 is -3. I add it, I get 1. 1 times -1 is -1. I add it, I get 2. Okay, that didn't work. Let's try a -3. Bring down my 1. 1 times -3 is -3. I add it, I get 1. 1 times -3 is -3. I added, I get 1. 1 times -3 is -3. I added, I get 0. So now I found a second 0. So I have x equal 3. And I am left with x squared plus, let me write it down here. I'm left with x squared plus x plus 1 equals 0. That's not factorable. I don't want to do completing the square. I'm going to use quadratic formula. So x is equal to negative b. So my b is 1, so it's a -1. This is my b right here. Plus or minus the square root of b squared, which is going to be 1 squared, minus 4 times my a, which is this one right here, times my c, which is this one right here, all over 2 times my a, which is 1. So I get x is equal to -1 plus or minus the square root of 1 minus 4 over 2. I put that into, well, I do that math. I get -1 plus or minus the square root of -3 over 2. That's imaginary answers. Okay, the square root of negatives and I. So I'm going to go -1 plus or minus I root 3 over 2. So I'm going to also have x is equal to -1 plus or minus I root 3 over 2. It's important that you try to break this down. Once you find, if it's a degree 4, once you find a degree 4, you break it down to a 3 and you take that as your new synthetic. Take your 3, break it down to a 2. Then once you get a quadratic, you can solve, because sometimes you're going to have radical answers or imaginary answers that you're not going to find otherwise. That's the end of this video.